Hello everyone, hope so all of you are fine. Today we're going to discuss about tuning fork test. First of all, we will discuss about principle of tuning fork test. These tests are performed by using tuning forks of different frequencies and auditory functions are assessed by comparing air conduction to bone conduction. Renitz test. This test compares the bone conduction with air conduction of the same ear of the subject. Plug one ear of the subject with cotton and test the open ear. Strike the tuning fork against the rubber pad to set it into vibrations. Place the stem of tuning fork firmly over the mastoid process of the subject at the level of upper portion of ear canal. Ask the subject to indicate when the sound disappears. Hold the tuning fork vertically with broad surface of prongs facing the external auditory meters 2.5 cm away from the orifice. If the subject can still hear the sound, it is termed as Renitz test positive, and if the subject has low air conduction, then the bone conduction, it is termed as Renitz test is negative. Renitz positive. Air conduction is better than bone conduction, that is air media can perceive what is not perceived by bone. Renitz negative. Bone conduction is better than air conduction. Conduction defect. Deafness. Renitz reduced positive. Air conduction and bone conduction both are reduced, but the normal ratio between air and bone conduction is still maintained. Renitz false negative. Both air conduction and bone conduction are absent in the ear being tested. The subject perceives the vibrations of tuning fork throughout the bones of skull in the other normal ear. Weber test. In this test, bone conduction of one ear is compared with the opposite ear of the subject. Set the tuning fork into vibrations and stem of tuning fork is placed firmly over the vertex of skull or forehead in midline. Ask the subject to point out to which side the sound is lateralized. Interpretation. Normal hearing. A subject with normal hearing will localize the sound as coming from the midline position. Conduction deafness. The sound will be heard better in the ear having defective middle ear function. This is because in the normal ear, the sound will be partially masked by the environmental noise to which normal ear is less sensitive. Also in the normal ear, the sound is damped by the tensor tympani and the stapedius muscles, which prevent the full amplitude of vibration of the auditory ossicles. Nerve deafness. In nerve deafness, while performing the Weber's test, the sound will not be heard better in the normal ear because neural activity is essential for hearing. Audiometry. A pure tone audiometer is an instrument for measuring hearing acuity. In this test, the subject listens to the several tones in the range of 125 Hz to 8000 Hz, usually at the octave or half octave intervals. The subject's threshold of perceiving each tone is determined and decoded as dB, decibels of loudness required to adjust hear each tone. If the loudness of a tone is required to increase 20 decibel above the normal tone level, the subject is said to have a hearing loss of 20 decibel for that particular tone. The amount of hearing loss is plotted on the audiogram below the normal hearing line at 0. Precautions. One ear should be tested at one time. Each and every step of performance should be discussed with the subject prior to test, and the examiner also have the normal hearing.